Hi, and welcome to this explanation of section 7.2, Substitution. This is part 2. In part 1, we covered question number 7 from our textbooks, and that question is a little bit more basic because it already has one of the variables isolated and by itself. If you have questions on how the substitution process works, and this is your first time studying it, then you might want to take a look at that part 1 video so that we can get you started with a more basic question. If you feel comfortable with that process, we're going to take a look at a slightly tougher question here in number 16. So why is 16 slightly tougher? Well, if we take a look at these two equations, we see 20x minus 30y equals negative 50, and we see x plus 2y equals 1. So unfortunately, neither equation has a variable by itself. So we need to first isolate a variable, meaning get the variable by itself, for us to be able to think about substituting it into the other equation. So what we want to do is take a look at these two equations and say to ourselves, which one looks like it would be easier to work with? Which one has smaller numbers? Which one seems like it's going to make for easier math? And between these two equations, I think this one looks like we have smaller numbers and it looks like it's going to be a little bit easier on us to isolate the variable. Since we don't have a coefficient on the x, I would recommend trying to isolate x in this equation. So if we want to get x by itself over here, what's our first step? If you said subtract 2y from both sides, you're correct. So to get x by itself, we need to get rid of the 2y. So x, after you cancel that out, will be equal to 1 minus 2y. Now similarly to what I did in video part 1 of substitution, I'm just going to surround what x is equal to with parentheses so that we can see where those parentheses get plugged in to our other equation. So now that we have x by itself, we're going to take this expression, 1 minus 2y, and we're going to substitute that in place of x in this equation. So we're going to have 20, and it's going to be 20 times 1 minus 2y. So rather than writing 20 times x, we're just replacing x with 1 minus 2y since those terms are equal. And then the rest of our equation remains the same. Minus 30y equals negative 50. Now from here, we have to distribute this coefficient to both terms in the parentheses. So we end up with 20 minus 40y minus 30y equals negative 50. Here we can combine like terms. Negative 40 and negative 30 would give us how much? If you said negative 70, you're correct. So we have 20 minus 70y equals negative 50. And to get y by itself, first we need to move 20 to the other side. So we subtract 20 from both sides. And we're left with negative 70y equals negative 70. And then here we divide by negative 70 to get y by itself. And we're left with y equals 1. Negative 70 over negative 70 gives us a positive 1. And just a quick reminder, we're not done. Once we find one of the variables, we have to plug it back in to solve for the other variable. And the equation that you pick is up to you, but my recommendation is pick the equation where you already have the other variable isolated. It'll make the math that you have to do a little bit easier. So in this case, if we plug in 1 in place of y into this equation, we get x equals 1 minus 2 times 1. So instead of y, we're writing 1 since that's what value y is equal to. And when we go ahead and solve that out, we get 1 minus 2, which gives us x equals negative 1 for our answer there. So we have x equals negative 1 and y equals 1 as our answer to question 16. If you'd like to see more explanations of section 7.2, then feel free to leave a comment. Otherwise, check out the videos for 7.3, 7.4, 7.5, and 7.6 as a good review for the upcoming chapter test. Thanks for watching.